Let's solve this nonlinear inequality. So nonlinear inequality, since we have a square, this is a quadratic. Quadratic is not linear. I want to make two videos. So in this video, I want to explain what happened when the other side is not a 0. And then in the next video, I want to solve another problem when the other side is 0. And I want to make that problem longer and bigger. Okay. Starting with this problem, let's move all the terms to one side because I want to see a 0 on the other side. So I will just do x squared minus 5x minus 14 greater than or equal to 0. So now I have a 0 on the other side. So what you have to do is you have to find the 0. So you have to the next step is find the 0. So to find the zeros, I have to treat the greater than or equal to as an equal. So whatever inequality signs you have, just treat that as an equal. So x squared minus 5x. You know what? I will just do it right here. So x squared minus 5x minus 14 equals to 0. And then I will perform the factor. So how do you factor that? I use diamond method all the time. So for the diamond method, I will just take the leading coefficient 1 times negative 14. So I have a negative 14. And then the coefficient of the x is negative 5. So this is a negative 5. So give me two numbers. The product is negative 14. The sum is negative 5. They are 2 and negative 7. Product negative 14, sum negative 5. And then you factor that. So you have x plus 2 times x minus 7 equals to 0. And then applying the 0 product property, you have x plus 2 equals to 0, x minus 7 equals to 0. So we have 2, 0, x equals to negative 2, and x equals to 7. So you have 2, 0. So 2 zeros. And then the next step is you have to build a number line. So let's change that to a different color, shall we? Let's change that to a different color. So for a number line, I'm going to draw a straight line. Okay, I'm going to draw a straight line and then place the zeros on the number line. So one is negative 2, the other one is positive 7, right? So that breaks this line down into 3 pieces, right? So you have one line to cut. So this is the first interval, the second, and the third interval. So let's draw those intervals. So the first interval, we have from negative infinity to negative 2. And then the second interval is from negative 2 to 7. And then the last interval is from 7 to positive infinity. Use open interval. I know there is an equal. We will take care of the equal at the end. So this is called the test interval. So test intervals. And then the next line is the test values. Test values. Test values means you pick a value within each interval. So this one, I will just pick x equals to negative 3. Since it's from negative 2 all the way down to negative infinity, you can pick negative 10, negative 100, negative 1000, or even higher values. But we are going to plug this in to the factors, so don't make it too big. I haven't seen students pick crazy values so far. So negative 2 to 7, pick something easy. 0 is easy. And then this one, I will just pick 8. You can pick 9, 10, 11, 12, whatever you like, as long as the number is in the interval. All right. And then we need to test the sign. The sign of what? The sign of two factors. So the sign of two factors, we have x plus 2. You know what? Before you find the 0, you can add another line right here. Before you find the 0, you can add another other line. You can factor that right here. I know I mentioned factor right here, but it is good to just factor it when it is an inequality. You can add that. Okay, because we will come back to this line. Okay, the sign of each factor, I have two factors, plus 2 and minus 7. Okay, so let's mention that x plus 2 and then x minus 7. And then you plug in. So you have a negative 3 plus 2, 0 plus 2, and then 8 plus 2. this will be a negative 3 minus 7, 0 minus 7, and then 8 minus 7. So that is a negative 1. This is a negative 10, 2, negative 7, 10. What? Do I really care what that equals to exactly? No, I don't. I only care positive or negative because we have greater than or equal to 0. I only care is that greater than or less than 0. So now, here is what I need to do. So this is a negative, this is a negative. We have a positive, we have a negative, and these both are positive. So here is my conclusion. Okay, so based on that, based on here, based on this, we want greater than or equal to 0. I factor the left-hand side. I want the left-hand side greater than or equal to 0. And then this is a multiply, right? We have a factor multiply another factor. So when you multiply two negatives, what do you get? Negative times negative, you get a positive. Negative times positive, you get a negative. Positive times positive, you get a positive. Since you want greater than 0, then I will pick these two positives. So the solutions are, so here is the solution. The first one is x less than or equal to negative 2, and then the other one is x greater than or equal to 7. You see that? So this is x less than or equal to negative 2, so that corresponds to this line. I can draw that line for you as well. So this is a negative 2, this is a positive 7, greater than or equal to 7. And then this is a less than or equal to negative 2. And then you have from negative infinity to negative 2. This time we add the square bracket because there is an equal, right? And then this one is from 7 square bracket to positive infinity. And then the last line right here, this is exactly what I want from your paper. So you are asking me to solve this inequality, right? X squared minus 5x greater than or equal to 14. X can be what numbers? Right? There are many numbers. X can be what number? All right. My answer is whenever you choose an x value, that x value must be either than negative 2 or less, or 7 or above. Right? You pick a number either right here or right here. Of course, including negative 2, including positive 7. All right, so that is the end of this problem. I don't want to make this video too long, so I have another problem to solve. Let's bring that to the next video. All right, I will meet you all there.